Now in part B, we're asked to find then a vector equation for any point on the line L1. So there's many versions that we could come up with, and that's why they say find a vector equation. There isn't the vector equation. So find a vector equation. How are we going to do it? Well, you should know that the vector equation will be given by the position vector r being any point from the origin to the line. Okay, so it can be any vector that comes from the origin to any point on the line, and r is always equal to a starting point on the line, and you can either take A or B as the starting point. Let's just suppose you take A, so you go from the origin up to the line. That will be the vector 2, 6, negative 1, and then you need to move along the line any amount of a vector in the direction of the line. Now, to have a direction vector that's parallel to the line, we might as well use the vector AB. So if I mark that vector on A to B, and we found that in the first part to be the vector I minus 2j plus 2k, so I could write that in as 1 minus 2, 2 as the direction vector. Then, as I say, to get to any point on the line, all we need to do is just simply take this vector and move it. Okay, so if I wanted to go, for instance, from O to say this point out here, I would need to go up here and do a couple of these vectors. So in general, if I move that vector just out to there, say, okay, that's the vector A to B. In general, then we've got that r can equal O to A, that's that, plus any amount, lambda say. You can use our alphabet, could say S or T or anything like that. I've chosen to use a Greek letter lambda. Lambda times the direction vector, and that would be 1 minus 2, 2. Of course, you could use the point B. You could go from the origin to B, so you could say that the position vector of any point on the line would be r equals, use the vector B, O to B I should say, 3, 4, 1, plus any amount, and it could be a different value from this letter here, lambda. Let's say we take mu, multiplied by the direction vector AB. So we could put that back in as 1 minus 2, 2. So here's just a couple of versions of equations that you could use for finding the position vector r of any point on that line L1. So that brings us to the end now of part B.